Hello students, we are studying 10th science first chapter gravitation. So in previous lecture we studied about the Kepler's three laws, also concept of gravitation, centripetal force. So today this is lecture number 2. We are going to study the next topic, that is Newton's universal law of gravitation. So depending on the Kepler's law, here Newton gives his famous law, that is universal law of gravitation. So all above consideration including Kepler's law led Newton to formulate his theory of universal gravity. According to this theory, every object in the universe attract every other object with a definite force. So see, the important statement is here, universal law of gravitation of Newton. So every object in the universe attract every other object with a definite force, and this force is directly proportional to the product of masses of two objects and inversely proportional to the square of distance between them. So this is very important law of Newton, that is the universal law of gravitation. So according to this law, Newton studied Kepler's three laws, and based on this Kepler's three laws, Newton gave the law of universal gravitation, that is the every object in the universe attract other object by a definite force of attraction, and that force of attraction is directly proportional to the product of their masses, that is that two masses of that two objects, and that force is inversely proportional to the distance, square of distance between them, multiplication of their masses directly proportional and inversely proportional to the square of distance between them. So consider, suppose two object in the universe. So till we know, uh, till in this chapter we studied that earth attract every object on the earth surface, or at the height from the earth surface, and that attraction force we called as the gravitational force. But gravitational force or gravity is attraction between every object, any object by a definite force is gravitation. Okay, and this law is given by Newton. According to Newton, every object in the universe attract other object by a definite force, and that force directly proportional to the product of their masses and inversely proportional to the square of distance between them. Suppose there are two objects. Suppose this is first object and this is second object. So this first object having suppose mass m1, and second object having mass suppose m2, and distance between these two objects is suppose d. Then according to Newton's law, the force between them is directly proportional to product of their masses, that is m1 into m2, and inversely proportional to the distance between them. So distance between them is d, so square of distance is d square. So that force directly proportional to product of their masses and inversely proportional to square of distance between them. So by solving this equation, we have to remove this directly proportional sign. So we take constant there. So we have formula F is equal to, we can write formula like this. F is equal to, here we can take constant as a g, so g into m1 into m2 and divided by d square. Now what is g? So g is the proportionality constant. When there is proportional sign, then we have to remove that sign and take a constant, that constant called as the proportionality constant. So here g is the proportionality constant, okay, and formula become f is equal to g into m1 into m2 upon d square. So this is a law, universal law of gravitation by Newton. So every object in the universe attract other object by a definite force, and that force is directly proportional to product of their masses and inversely proportional to distance, square of distance between them. Okay, then see here formula is given, same formula. Then see, we have to find the unit of this gravitational constant. Okay, universal gravitational constant, that g is called as the universal gravitational constant. Now we have to find the unit of that universal constant. Okay, so see what is unit of this universal constant. So for this, first we have to write formula for that gravitational constant. So formula for g, so g is equal to this d square become multiplied to f, so f into d square and divided by m1 and m2 become divided, so m1 and into m2. Now here put the units of each term. So g is equal to, here force, so force has SI unit, SI unit of force is Newton, into d square, so distance, d is the distance, so SI unit of distance is meter, and as there is square of d, so this become meter square, divided by m1. M1 is mass of first object, so mass of first object is SI unit is kilogram, into m2 is mass of second object, again second object have same mass, that unit, that is kilogram. Now if we simplify this, we get formula or unit of g. So unit of g is equal to, unit of g is equal to this Newton into meter square, and this kilogram into kilogram become kilogram square. So here, I have to write unit of g is equal to Newton meter square and this kilogram square. We can write this as inverse because this kilogram is at the denominator, so when we take it to the numerator it become inverse. So Newton meter square per kilogram square, this is unit of g, that is g is universal gravitational constant. Okay, so this is unit. So here you can see unit is given Newton meter square per kilogram square, and this value of g is calculated by a scientist, and that scientist was the Henry Cavendish. So this Henry Cavendish calculated the value of g, and value of g is 6.673 into 10 raised to minus 11, and see the unit of g is Newton meter square per kilogram square. Okay, so this is about the universal law of gravitation. Now here the above law means that, see this line, if the mass of one object is doubled, the force between two objects also doubles. So if we double the mass of one object, then the value of force is also double. We can explain this like this. So we have formula: force is equal to G into m1 m2 divided by d square. Now if we double the mass of any one object, suppose we double here mass of this first object, so here we have to write 2 m1 into m2, then we have to multiply to the left side by 2, so force also become double. If we triple the mass of one object, then we have to multiply force also by 3. That is, when we triple the mass of one object, force also become triple. When we increase mass of one object by 4 or multiply by 4, then force also multiply by 4. Okay, so this is about mass and force. Then what is about distance? So if we double the distance, now see, if we double the distance, this same formula is here. Now if we double the distance, that is, distance become here twice d, then here distance square is there, so this twice d square, so this twice d square become 4d square. Okay, and that 4 is divided to the right side, so here we have to divide left side also by 4, and so force is decreased by the factor 4. If we double the distance, then force decrease by how many factor? By 4 factor, because there is square of distance. So if we double distance, after squaring it become 4, so force decreases by factor 4. Now similarly, if we triple the distance, now if we triple the distance, then this become 3d and square, 3 square become 9 and d square become d square, so 9d square. And as this 9 is divided to the right side, we have to divide this left side f by 9, so force decreases by 9 factor. Okay, so if we triple the distance, force decreases by 9 factor. If we double the distance, force decreases by factor 4. So this is about decreasing or increasing distance and masses. If we increase mass, by same factor force also increases. If we double the mass of one object, force also double. If we triple the mass of one object, then force also tripled. And opposite to this, if we double the distance, then force decreases by factor 4, and if we triple the distance, the force decreases by factor 9. So this is important point here. Okay, so this is about the universal law of gravitation by Newton. So what is statement? Statement of this universal law is: every object in the universe attract other object by a definite force, and that force is directly proportional to the product of masses, product of their masses, and inversely proportional to square of distance between them. And formula become F is equal to G into m1 into m2 divided by d square, where G is universal gravitational constant, m1 is mass of first object, m2 is mass of second object, and d is the distance between them. Okay, Then g is the universal constant, and that universal constant have unit, as we calculated. Unit is Newton meter square per kilogram square, and the value of g is calculated by the scientist, that is Henry Cavendish. And according to Henry Cavendish, value of g is 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. Okay, so this is one of the important topic in this chapter, universal gravitational law of universal gravitation by Newton. Okay, so we'll stop here. We'll continue next topic in the next lecture.